Okay, so I'm going to start off by solving problem number 2. And what the first step I did was I just put it in simpler terms for me to solve. And so basically what this problem is saying is x to the power of 3/4. And from there I integrated by using the power rule, which you add 1 to the exponent and then you divide by whatever the exponent came out to be. And so once you add that, it becomes x to the power of 7/4, and then you would divide it by 7/4. From there, you basically just want to simplify, and so once you simplify this problem down, it comes to 4x to the power of 7/4 over 7 plus c as constant. And so I'm going to move on to the next problem. So for the next problem, I had solved the entire thing by using this formula, which is final velocity equals initial velocity plus acceleration times time. And from there, I just wrote down whatever I had already known. So I had known that it had given us 80 as initial velocity, and then for acceleration was -32. And from there, the first thing that you were to solve was for time. And so I had used this formula and I plugged in what I knew to solve for time. Reason being I had put 0 where final velocity was is because at the point where the ball was up in the air, the velocity was 0. And so really the final velocity for the ball then would have been 0 since the ball was not in motion. So after solving that all out, you would just have to do simple algebra. So this would be -80, -32, and then you would divide it, which makes t equal 2.5. But that was not the end of it. So 2.5 had only meant either the ball was going up or the ball was coming back down. Since the problem had asked for the whole time, you would have to calculate from when the ball went up and down. And so technically that would count as times 2 since it went up once and then back down, which would come out to be 5 seconds. After that, I had solved for the final velocity. So for final velocity, since that's what we were solving for, I had left it blank. And then I plugged in what I had already known. Since it had asked the final velocity of impact. So after doing that, you just solve it regularly. So it'd be 80 plus -160. So -80 ended up being the final velocity, and it'd be feet per second. So for time, I had gotten 5 seconds, and then for final velocity, I received -80 feet per second. So for the next problem, the first step that you would do is that you would take the antiderivative of the function. And so you would just integrate that once again, and I would just use the power rule. So x squared over 2 minus x. Really, you could divide it by 1, but since it's just 1, it would cancel out. And then from there, you would want to plug in the points that it gives you from here. And so I would just plug these points into the problem. And so I'd do 6 squared over 2 minus 6, and then subtract it by 0 squared over 2 minus 0. The reason being that you would do 6 first is because these 2 points are labeled as A and B. And so in the formula that we were given, you would always do b minus a. And so it really didn't matter what kind of values you had here. You would just take this top value subtracted by this one. And so once you evaluate that, that comes to be 12 minus 0, leaving the final answer to be 12. And then in problem number 8, what I first did was, once again, I made it into simpler terms. So I changed the square root of x to x to the 1/2, and then I simplified that once again. This, you would see it as almost like the power of x to the power of 2 over 2. And so when you multiply them together, they add, their exponents add, so then it'd be x to the 3 over 2. From there, you would want to integrate, and so I did that by doing the power rule. And so it'd be x to the power of 5 over 2 divided by 5 over 2. And once again, you just want to plug in these points that you were given, so 4, 1, and then plug them in, subtract them, and then you would receive your answer. And so after plugging them in, 4 to the power of 5 over 2 divided by 5 over 2 minus 1 to the power of 5 over 2 minus 5 over 2. Once you solve these down and simplify them down, this becomes 64 over 5 minus 2/5, which equals 62 over 5. And that is the solution for that one. And for the last problem, it was a problem of the second fundamental theorem of calculus. And so what this one had us do was basically, from the range that we were giving, you would plug in each of these problems into this, but since they had used a constant, the constant doesn't really matter because it would X out anyways and cancel out. So what points did matter was any points that had an X value. So for here, I'm only going to do X to the 3rd power. And so what you would do is you would plug this in for where t is at. And so I'm going to do that. And since t was to the 3rd power, I'm going to still keep the 3rd power there. And then from there, you would just take it by the derivative. You would just multiply it by the derivative. So it would be 3x squared. After that point, you just simplify. And so I'm going to simplify this down to 1 over x to the 9th. And then this would become 3x squared over x to the 9th. And since you can simplify that even more, you would go down to 3 over x to the 7th. And that would be the final solution to the problem. And that is me solving all the problems.